to how containers are different from the virtual machines. Here, let's delve more into this and understand it. We know that the containers run on the Docker engine, whereas the virtual machines run on a hypervisor. Containers share the kernel from the host operating system and only adds the application binaries, libraries, and dependencies. Whereas a virtual machine runs a full operating system with its own kernel, memory management, and virtual device drivers. The diagram here on this slide just depicts that. In case of virtual machine, each virtual machine has its own operating system, the binary and the library files, and the applications running on top of it. Whereas in case of containers, we have the containerization engine, which is Docker, and on top of that, each container holds the binary files and the dependencies, and of course the applications running on top of those. You might want to pause the video and take a detailed look at it. In the next slide, I have listed down the differences, some of these differences. Containerization technology is the abstraction of the application layer. On the other hand, virtualization technology is the abstraction of physical hardware and providing it to the multiple instances. Containers takes very less space. Typically, size of a container is in terms of some MBs. Okay, whereas the virtual machines are huge and each virtual machine is in the tune of gigabytes. Next point on difference is the boot up time. Containers take few seconds to start, whereas the virtual machines take minutes. Irrespective of what hardware configurations they have, they will take that much time. Containers have a layered file system. Virtual machines don't have this concept. Every virtual machine comes with its own independent full-size file system. Virtual machines have a very high degree of isolation between them. Containers don't have that level of isolation but are lightweight on the resources. In case of containers, data is generally outside the container on a volume. So even if the container is deleted, the data stays and can be reused with another container. Thus, backup of the container data is not needed even in production systems. For virtual machines, the running virtual machines can be preserved as multiple snapshots. These snapshots are, however, heavy on disk size. There is also difference between the way containers and virtual machines are built. For a container, we start almost from scratch and include exactly what is needed. In case of virtual machine, they start with full operating system. Depending on the application, developer needs to strip out unwanted components to make the virtual machine lightweight. And lastly, the containers provide an inherent support for microservices based architecture, whereas virtual machines are monolithic in their approach. Okay, so let's move on to the next slide. Now, here is an interesting slide. So far, we have always spoken about containers and virtual machine in a competitive way. However, containerization and virtualization can coexist and very well complement each other to derive the best out of the hardware resources that we have. Docker containers can run on Docker hosts, which are themselves running as virtual machines. Using them both together provides quite a few advantages. The cloud infrastructure is mostly virtual machines based. Having Docker host on bare metal provides maintenance challenges. Bare metal doesn't give rollback features also. So basically, you have a hypervisor running on the physical hardware. Multiple Docker hosts can run as virtual machines on that hardware. Plus, you can have other virtual machines which are not containerized running on the same hypervisor. Each Docker host in turn runs multiple containers, which can be seen in this Docker host. At this point, it would be good to understand where the images and containers fit in the perspective of a production system. In this nugget, we will gain some understanding about the Docker ecosystem and how it provides a robust and fast environment. The microservices architecture emphasizes on two key aspects, that is service discovery and load balancing. In the actual deployment, there isn't going to be one container providing a service. We need to run multiple containers to provide robustness and to prevent overloading of a single instance. It also gives us the opportunity to increase the number of containers during the times when the load is expected to be high. Service discovery is required to identify the nodes that are providing a particular service. As soon as an instance is made up and it is ready to run, it informs the load balancer about its availability so that it can also be considered for handling the load. Of course, it provides a scalability and flexibility to the solution. It provides a great amount of scalability and flexibility to the solution. The second aspect of the microservices architecture is the load balancing. Load balancers distribute the traffic across the nodes available to provide the services. This helps to minimize the response time and also avoids overloading of a specific container. It gets the information of the nodes from the service discovery aspect of the ecosystem. Once the node is added, the load balancer maintains a list of all the nodes available. It also does regular health checks to verify that the nodes are still available or not to provide the services. In the diagram, the request flow from the external network is displayed. Firstly, the FQDN gets resolved to an IP address of the load balancer. The load balancer routes the request to one of the available nodes providing the service over the internal network. The external user remains oblivious of these details and gets his desired response. As the scale of the operation increases, it becomes nearly impossible to manage the entire infrastructure manually. Therefore, the need of orchestration arises. It provides an automated deployment configuration and management of container-based applications. Let's have a look at some key responsibilities of orchestration tools. Very first is your automated deployment and provisioning of containers. Command is generally given through external sources like web applications or web services calls. Scaling up or down on the containers as the need arises. We can have predefined allocation of resources for each container for memory and CPU, so that becomes that much more flexible. In case of issues with host, maintenance or overloading, it is expected to move containers across hosts. Constantly monitor the state of the containers using liveliness checks and take corrective actions in case there are any issues. Let's have a look at some of the popular orchestration engines that are available. So those are your Docker Swarm from Docker family only. We will cover it in this course, so we'll be talking about that in detail. Kubernetes, it's an open source project by Google. Marathon is the orchestration platform for Mesosphere's data center operating system, DCOS as it is called, and Apache Mesos.